the inside of our payload, we have our GPS, our spot trace, and it's just stuck there with tape and Velcro. And then there's our camera. And as you can see, it's not really secured yet, but that's because we need to turn it on when we get to our launch site. So when we get there, we'll turn it on, put it through the slot, clamp it down with this wood block from here to here, and then tape it all up. And once we've done that, we're gonna put the lid on. And in order to secure the lid, we are planning on zip tying through these holes right here. So the zip tie will go through one hole, out the hole to the side here, and then we'll zip it down here, and then we'll duct tape the entire thing. And so what's connecting the payload to our radar reflector is fishing line. So we used like double layer fishing line and connected it to this radar reflector here. So basically just made it out of cardboard, but because we made it out of cardboard, the fishing line, when we first put it through, it actually like tore through the cardboard, and so that's why we had to add these extra like support cardboard pieces, and we put electrical tape through them as like a sort of gauge, because we don't want it to like rip off when like the parachute opens. And so on the other side of our radar reflector, we have our parachute, and it's basically just tied down with zip ties. Okay, so our parachute here didn't come with a handle like most other parachutes, so we had created our own little ring made out of this flexible metal, but it's pretty sturdy. And so we just sewed it on, and what we plan on, like the reason why we need to do this was so that we can connect our balloon. So how are you going to connect the parachute to the balloon itself? So what we did is we tied the string here and made a loop right over here, and then our parachute right over here. We created 3 equal lengths of fishing line. So this is 4 feet long, and then we tied, as you can see, knots in the corners, not really corners, but in a triangle formation, and we hot glued them so that they wouldn't slip off. And then we taped them and glued them and tied them all up to this carabiner here. And then on the day of launch, we're going to take the loop that's connected to the balloon and the carabiner and just slip it on. And then probably tape this part here, and then it'll be all ready to go. The balloon will be connected to the parachute, will be connected to the radar reflector, which will be connected to our payload. So how our string is connected to our balloon is through this. We have two knots on one side and one side on here, and then we slipped a zip tie through them and bolted it onto this PVC pipe that we stuck through the hole of the balloon, and we just taped the outside of it. To make sure we have the right amount of helium so that we have the right amount of lift, we plan on doing is attaching this hook to fishing line and connecting that to the helium tank, and then putting another fishing line through this hole, and that's going to connect to the balloon. So when the balloon is blown up, we'll know the amount of force that the balloon uses, I guess. So this is a balloon performance calculator, and what we did is we inserted our balloon size. So our balloon is 600 grams, and we put in the weight of our payload, which we measured with a scale. And then what we did was we added an estimated amount of positive lift that we needed. We didn't know exactly how many we needed, but we knew that we wanted our balloon to ascend at a 5 meters per second rate. And so what we did was we just changed this number until we achieved this number here. So when you press calculate, this calculator will emit like the amount of helium that you need. And so this says we need 111 cubic feet of helium, and so that's why we have 2 60 cubic feet helium tanks. So that's 120 cubic feet of helium. So we have more than we need, which is really good. However, how are we gonna determine when to stop pumping helium into our balloon? So that's where positive lift comes in. So once we use our force sensor, we will be able to determine how much positive lift we have, and then once we reach 1,000 grams of positive lift, we will stop the helium from flowing through the balloon. And so yeah, this is what you need. This is all the data and information you need in order to predict where your balloon is going to land. So here is the CUSF landing predictor 2.5. So what you would do is you would insert a coordinates of where you want your balloon to launch from. So we put our coordinates here. The launch altitude, what is the altitude of your launch location? When do you plan on launching your balloon? So we plan to launch it at 10 a.m. tomorrow. And the ascent rate, we said 5 meters per second. And our burst altitude is what we calculated here. It's right here, estimated burst altitude. So we copied and pasted that number into here. The descent rate, well, that was already given to us. I think it's pretty average on everyone's part. So you run the predictor, and as you can see, luckily our balloon doesn't travel very far. We picked a good day where there was no winds. However, the weather is really unpredictable at times, so you're gonna have to run the simulation many times. So we plan on running the simulation again tomorrow morning in order to find a better place where the balloon will land. But we know that it will head in like a southeast direction.